Google DeepMind just dropped something that changes how we see inside AI models. And honestly, the AI safety world is still trying to wrap their heads around what this means. We're talking about Gemma Scope 2, a complete set of tools that let researchers look directly into how AI thinks, covering every single model size from 270 million to 27 billion parameters. And the crazy part is, creating this thing required storing 110 petabytes of data and training over 1 trillion total parameters. That's bigger than anything any other AI company has ever released to the public for safety research. Let me explain why this matters and why every AI researcher should be paying attention right now. So here is the thing. When you ask a modern AI model a question, it gives you an answer. But what happens inside its brain between your questions and its answer has always been a complete mystery. Even the engineers who built these models can't fully explain why a model suddenly decides to refuse a request or why it starts making up facts out of nowhere. It's like having a super smart assistant who gives you perfect answers, but you have no idea how they actually think. That's the black box problem, and it's been sitting at the heart of AI safety for years. Gemma Scope 2 attacks this problem head-on by building what Google calls a microscope for AI models. The first version, Gemma Scope, already helped researchers study things like model lies, finding secrets hidden inside models, and training safer AI systems. But Gemma Scope 2 takes everything to a completely different level. It covers all 5 sizes of Gemma 3 family, which includes models at 270 million, 1 billion, 4 billion, 12 billion, and 27 billion parameters. And it doesn't just cover 1 or 2 layers inside each model. It covers every single layer and sublayer across all of them. That's full coverage from the smallest model you could run on your phone all the way up to massive ones that need serious computing power. Now let's talk about the numbers because they are actually insane. To build Gemma Scope 2, Google stored around 110 petabytes of data and trained over 1 trillion total parameters. To give you some perspective, that's more data than most research labs will ever touch in their entire lifetime. And this isn't Google keeping things locked up inside their walls. They're calling this the largest ever open source release of tools for understanding AI from any AI lab. That means anyone, any safety researcher, any university team, any developer can download these tools and start poking around inside Gemma 3 models to see exactly how they work. The technical piece that makes all of this possible is something called sparse autoencoders, or SAEs for short. Think of these like spatial filters that take the messy, super complicated math happening inside an AI model and break it down into simple pieces that the humans can actually understand. When a model processes information, SAEs expand dense activations into large, more spread out forms that reveal what the model is thinking about. So for example, if you feed an email into Gemma model and ask if it's fake, the SAEs can show you which internal features light up when the model detects words like urgent or click here now. It's like being able to see which neurons fire inside a brain when someone recognizes a phrase. But Gemma Scope 2 doesn't stop at just logging at one layer. It introduces something new called transcoders and cross-layer transcoders. These tools let researchers follow information as it moves through the entire network. So if the model decides to refuse answering a dangerous question, researchers can now trace that decision backward through every layer to see exactly where and how the refusal was triggered. This makes it much easier to understand multi-step thinking and complex patterns spread across the whole model. That's huge because most safety problems, like when a model gets jailbroken or starts lying, involve many layers working together in ways we couldn't track before. And honestly, the training process itself is worth talking about. Google used a cutting-edge method called Matryoshka training. This technique helps the SAEs find more useful patterns and fixes some problems that showed up in the original Gemma scope. In simple terms, it makes the system better at picking out the features that actually matter instead of getting lost in noise. The team also built special tools just for chatbot behavior. These tools let researchers study things like jailbreaks, which is when someone tricks the model into breaking its safety rules. They can also look at refusal systems, which is how the model decides to say no to bad requests. And they can check something called chain of thought faithfulness, which basically means whether the model's internal reasoning matches what it tells you out loud. Let's get specific about what this means in practice. When a Gemma 3 model gets jailbroken, lies, or acts overly agreeable, researchers can now see which internal features activated and how those activations followed through the network. Imagine someone sets a prompt designed to bypass safety filters. With Gemma Scope 2, researchers can watch the exact moment the model's refusal system gets turned off. They can see which features were supposed to fire but didn't. They can trace the path of the jailbreak through every layer. That's not speculation anymore. That's direct observation of what's happening inside the model's decision-making process. The scale of this release also matters because certain AI behaviors only show up in bigger models. There is this thing called emergent behavior, where a model suddenly develops abilities it wasn't specifically trained for once it gets large enough. By covering models up to 27 billion parameters, Gemma Scope 2 lets researchers study these advanced behaviors in large language models. And honestly, that's critical because if you want to understand AI safety problems that might appear in the most powerful systems, you need tools that work on large models. That's where the interesting and sometimes dangerous behaviors appear. One of the key technical advances in Gemma Scope 2 is how it extends coverage across the entire model architecture. The original Gemma Scope proved that sparse autoencoders using the JumpReLU architecture could effectively break down what models are thinking. Gemma Scope 2 takes that same approach and scales it up to dramatically, training SAEs and transcoders for every layer across all 5 Gemma 3 model sizes. What this means in real terms is that the features researchers can identify are now comprehensive across the entire model family, making it possible to compare how different model sizes handle the same concepts. But even with the massive scale, the impact is already real. The first Gemma Scope enabled research on model lies, finding hidden knowledge inside models, and building safer training methods. Gemma Scope 2 pushes all of that forward by giving researchers 4 massive upgrades. First, full model coverage across the entire Gemma 3 family up to 27 billion parameters. Second, SAEs and transcoders trained on every single layer. Third, advanced training methods like Matryoshka that produce better features. And fourth, special tools built specifically for analyzing chatbot behavior like jailbreak, refusals, and whether the model's reasoning is honest. And here is where it gets even more interesting. Google didn't just release the tools, they also partnered with Neuronpedia to build an interactive demo that anyone can try right now. You don't need to write code, you don't need a massive server farm. You can just open the demo, feed in a prompt, and watch how different features light up as the model processes your input. That's a level of access that just didn't exist before. Researchers can search through features, test their own examples, and trace how information moves through the network, all through a web interface. The safety applications are the real reason this matters so much. Google says they want researchers to use Gemma Scope 2 to find bugs in emerging model behaviors, ODDI agents, and speed up the development of practical safety fixes for problems like jailbreaks, lies, and models that agree too much with users. The last one, called psychophancy, is when a model tells you what you want to hear instead of what's actually true. It's a subtle problem, but it can be really dangerous in situations where people rely on AI for important decisions, and the community is already paying attention. Within hours of the release, AI safety researchers started posting about it online. People are excited because this is one of those rare moments where a major company doesn't just talk about transparency, they actually seek the tools to make it happen. OpenAI and Anthropic keep their advanced model internals private. Google's strategy is completely different. They are betting that opening up their models and giving away powerful analysis tools will lead to better safety research from the whole community. It's a crowdsourcing approach to AI safety, and if it works, it could change how the entire industry handles risk. Now, in fairness, not everyone can use these tools effectively. While the software itself is free, Actually, running deep analysis with these SIEs requires serious computing resources. The sheer scale of 110 petabytes of trained data and over 1 trillion parameters means you need significant hardware to work with the full toolkit. This limits the practical use of Gemma Scope tool to well-funded research labs, universities with strong computing resources, and companies that already have the hardware. But that's still a huge upgrade from the previous situation where almost nobody outside of Google could even attempt this kind of work. The bigger picture here is that Google is positioning itself as the main enabler of OpenAI safety research. While their competitors keep things locked down, Google is handling out both the models and the microscope. That's a bold move because it means other teams will find bugs and weaknesses in Gemma models faster, but it also means those bugs get fixed faster and the lessons learned spread across the entire field. It's a bet that transparency and open collaboration will lead to safer AI faster than secrecy and internal-only research. One detail that really shows how serious Google is about this, the release includes not just the pre-trained models, but also the instruction-tuned SAT versions. That means researchers can study both the raw model behavior and the behavior after safety training. They can compare how features change between the two versions. They can see which safety mechanisms get added during instruction tuning and whether those mechanisms actually work the way they're supposed to. That kind of before and after visibility is incredibly valuable for understanding what safety training actually does. The timing of this release is also interesting. We are in this moment where AI capabilities are exploding, but safety research is struggling to keep up. Models are getting smarter, more powerful, and deployed in more places. But our ability to understand why they do what they do hasn't been keeping pace. Gemma Scope 2 is Google's way of saying, here's the toolkit you need to catch up. It's not perfect, it's not complete, but it's the most comprehensive set of tools any company has released for looking inside modern AI systems. The technical paper that came with the release is also worth mentioning. It lays out exactly how the SAEs were trained, what evaluation models they used, and where the current limitations are. That level of detail is rare. Most companies release tools with a blog post and some examples. Google released a full academic paper with methods, results, and honest discussion of what doesn't work yet. That's the kind of transparency that builds trust in the research community. So where does this leave us? AI safety just got a huge upgrade in terms of available tools and data. Researchers can now look inside models in ways that weren't possible a month ago. They can trace jailbreaks, study lies, investigate refusals, and check whether models are being honest about their reasoning. All of that matters because as these models get deployed in more critical situations, healthcare, legal advice, education, financial planning, we need to know they're working correctly. We need to be able to spot problems before they cause real harm. That's where we will wrap it up. One thing I'm really curious about is how fast the research community picks this up and what they find. Because if Gemma Scope 2 helps researchers discover new safety problems or better way to fix them, that knowledge will spread to other models too. Even the ones from companies that don't release their own tools. Drop your thoughts below. Make sure you are subscribed, hit the like button, and I will see you in the next one.